In another video, I talk about the rules for drawing bond line structures. In this case, we're going to look at some specific examples of that. So here we're given a Lewis structure, and we want to draw the bond line structure for this compound. So what I like to do is determine what is my longest chain of carbon atoms. Right, so here I have 1, 2, 3, 4, 5, 6, 7, and then they're all either sp3 or sp2 hybridized, and so I can use zigzags to represent all of these. And so I'm going to do 7 in a zigzag. And so the first one, so that's 1, 2, 3, 4, 5, 6, 7. All right, and then after that I can go in and fill everything else in that I need to. So I don't need to draw any of the hydrogens, at least the ones that are connected to carbon. And then I have between the between the second and third carbons, I have a double bond. So that's between these two here. So I need to put in the double bond. And then on the 1, 2, 3, 4, fifth carbon, I have an oxygen. So 1, 2, 3, 4, 5. So I need to show the oxygen, and then the hydrogens that are connected to the carbons, I don't have to show. But any hydrogens connected to anything that's not carbon, I've got to show it. So I've got to tell you that it's an OH. All right, and then I think I mentioned this in the other video. Whether we draw the lone pairs or not kind of depends on exactly what we're doing. In this case, since they showed me the lone pairs in the Lewis structure, I'll go ahead and put the lone pairs on in my bond line structure. Okay, here's another example where they've given it to us in the condensed format. And so, as I said in the video where I looked at specifically condensed structure examples, what I usually do is draw out the molecule ignoring the parentheses, and then I'll come back and fill in the parentheses in the end. And then, now I don't have just carbons in my chain, I've got an oxygen, but all my carbons are either sp2 or sp3 hybridized, so I can use the zigzags. So I've got 1, 2, 3 carbons, and then the oxygen. So I'll do, right, here's 1, 2, 3 carbons, then the oxygen. Then I have 2 more carbons, so 1, 2. And I'll go ahead and fill in the parentheses now. So on that last carbon, I've got 2 CH3s. So there's 1, and then for the other one, what we usually do is that. All right, the other thing I have to fill in here. The oxygen was only attached to carbons, so he's good, and I just need to put the double bond in between carbons 1 and 2. Okay, here's a cyclic structure. And again, what I usually do is start with the carbons and then fill everything else in. And so I have a 5-membered carbon ring, so it forms a pentagon. So if I draw a pentagon, that takes care of my carbons, right? And then at each one of these corners is one of the carbon atoms. And then I just need to fill in this case, the things that aren't the hydrogens. So on one of the carbons, I have a double bond to an oxygen, and I'll go ahead and put in the lone pairs. On the carbon to the left of it, I have a fluorine. And on the one to the left of that, I have an NH2. And again, since I put the lone pairs in the Lewis structure, I'll go ahead and put them on in my bond line structure. Okay, one last example. I think it's worthwhile to talk about triple bonds. So when I have to do triple bonds, I got to remember I've got to make them linear. And so what I usually do is start by drawing the triple bond and then draw the other atoms coming off of that. So there's my triple bond. To the left of the triple bond, I've got 1 carbon. So I need to make it linear. Right, so here's carbon 1, here's carbon 2 of the triple bond, here's carbon 3 of the triple bond, and then on the other side of the triple bond, I've got 2 carbons. So the first one needs to be coming off linear, and then I can start using zigzags for the second one. Right, so let's double check this. I have 1, 2, 3, 4, 5 carbons, and I have 1, 2, 3, 4, 5 carbons. And then there's nothing else but hydrogens, and so that's all I need for that structure. Okay, let's go in the other direction. So let's go from the bond line structure to the Lewis structure. Really, the only tricky thing about going in this direction is you got to remember to count the hydrogens right. And so what I usually do is put in the carbons, then put in everything else, and then lastly I go in and I fill in the hydrogens. So I have 1, 2, 3, 4, 5, 6 carbons. So I'll do my 1, 2, 3, 4, 5, 6 carbons. On the second one I have a bromine. Then on the third and fourth carbons I have a double bond. And then on the second to last carbon I have a double bond to an oxygen. All right, so now all I need to do is fill in my hydrogens. So in that first carbon, it's only got one bond. So that means it must have 3 hydrogens. Because again, right, carbon has to have 4 bonds. Right, my next carbon already has 3 bonds, so it only needs 1 hydrogen. Next carbon also has 3 bonds, so it needs 1 hydrogen. Same thing with the next one. All right, the next carbon already has 4 bonds, so he's done. He doesn't get any hydrogens. The last one only has 1 bond, so he needs 3 hydrogens. All right, one more example. Okay, so here I have another cyclic structure. It's got some double bonds. It's got something coming off the cyclic structure. What I'd probably do is go ahead and draw my 6 carbons in a hexagon to start with. All right, I've got a carbon, right? At this end point here, I have a carbon. So I'll put him in. So I've got all my carbons. Now let me put in the double bonds. And then lastly, I'll fill in the hydrogens. So the one sticking out at the top, there's just 1 bond, so he needs 3 hydrogens. Right, this carbon has 1, 2, 3, 4 bonds. He's done. This carbon has 1, 2, 3 bonds, so it needs 1 hydrogen. And the same thing with the other hydrogen, or the other carbons around the ring. They all have 3 bonds. They all need 1 hydrogen.